So what I want to tell you, though, is even though this is in part definitely true, it's in many important ways not true. So that there is a different empirical tool here, and that different empirical tool can be super useful, but it is different. So let's go back to the data set on words and sentiment analysis. So this is a table from that data set, from that paper. And here's what they have. They have each row is going to have, remember how I said we're just predicting a y variable, positive, negative sentiment. And in predicting y, you just need x's. So each row tells you what are the x's I'm using, how many of them are there, and am I merely using frequency or presence? I'll explain what I mean by that. And my performance out of sample in a different, in another set of movie reviews. This is accuracy. So you can see, scanning the table, you can get up to about 82, 83% in this table, in the way they're doing it. So what I'm putting this up for is for you to understand what features they're actually using. So unigrams are a basic building block of a lot of natural language processing. What you would do is you would just take a piece of text and you would say, let's write down all the words in any of the reviews I've seen. So this is word 1, this is word 2, sucks, et cetera, et cetera, et cetera. Then you would, just like we took every photo and simply made it a vector of pixels, we're going to take every review and make it a vector of words. We're going to say, now that's where the presence or frequency comes in. Frequency would be counting how many times is the word the in. Presence would just be 0, 1. That's unigrams. What's lost by taking a movie review and putting it and just saying it's a vector of unigrams? All the sentence structure. There's no ordering anymore. So if I say, the job sucks. Oh, this is not going to end well for me. Let's not use that sentence. Let's just not use an example on the fly. The point is that the ordering of the words is completely lost. All the sentence structure is lost. But that is one set of x's you could generate. Here's another set. These are called bigrams. Bigrams are, instead of saying the shirt and making each a word, you could have one thing be the shirt, because that's a very common bigram. So you could say, what are all the bigrams that I see? And then I could go on like that. But now, of course, you see what's lost. Trigrams. You can see how far you can keep going with this. There are other things here which I won't get to because I don't want to get into the depth of natural language processing. But that's vectorization. It's sort of taking what looks like a piece of, doesn't even look like data. You would never have looked at a movie review and say that's data. But by vectorizing, we've sort of made it data. The thing I want you to focus on is this number. So I did the aside on vectorization. I want you to focus on those things. Now, you might remember I told you they had 2,000 data points. And now what I have here is the number of x variables. It turns out that for unigrams, there are about 16,000 distinct words in their movie reviews, in their 2,000 movie reviews. And so what that means is every movie review in their data set is now converted to a vector, in the unigram case, that's 6,165 long. And that's what they're using. Something strike you as odd about that? Yeah.
It's really high-dimensional.
Yeah. You would think that one of the things you shouldn't do is run a regression with, 16,000 variables when you only have 2,000 data points. In fact, not only is it something you shouldn't do, it's something you can't do. That matrix is not invertible. So this really should not be possible. It's easiest to see in the linear case. It's literally not an invertible matrix. So you can go back and look at this, n data points, k variables, x prime x is not invertible. Just think about computing the OLS coefficient. It's not going to work. It's just, it's got higher rank than the number of data points. So then you say, how on earth is this even possible? That's the big pivot here. You use the word high dimensional, but that's the enormous pivot. It is really important to understand that at some point, a turn is made. That turn is kind of seen here. I'll show you a few other examples. When the data is very wide, maybe has a lot of variables, or it's high dimensional in some way. And usually these things reach a point where you just, if you just went with the techniques that you have in nearly all of econometrics and statistics, it's not just that they don't work well, they don't work. They can't work. They're not, it just doesn't make any sense. Does that make sense to everybody? If you want, take time and try and run a regression with 200 variables and 100 data points, or try and invert the matrix. It's just not invertible.